Alright, this is lesson 29 for Algebra 1. Today we're evaluating functions. When we evaluate functions, it means we're going to think about functions, which are the idea of like we're putting ingredients into a machine, a function is a math machine, okay? And when you put an ingredient in, you should get how many outputs always? One output, right? Like if I put all the cake mix in, right? And get all those ingredients, there's only one thing that should come out, just cake, right? It shouldn't come out with any other thing, right? So, because otherwise it's not a function. So when I put a number into a math equation or a function, there's only one number that comes out. So today we're going to get numbers, and we're going to see what numbers pop out of the machine. So this thing on the bottom called a piecewise function is a, let's say we had a rule that we had two machines, okay? Let's say we had two machines. One machine says only used for baking, okay? This other machine only used for barbecuing, okay? So I have an ingredient. I have flour and sugar and baking soda. So should I put it into the baking machine or into the barbecue machine? Baking, right? We're not going to put flour on our barbecue, right? Is it going to work? No. But let's say I got like ground beef and some other, meats and veggies and stuff, and I wanted to create like a barbecue. Will I put it into the baking machine or the oven, or should I put it into the barbecue? Barbecue, right? Okay.
You do either.
Well, technically, yeah, you could. So, but for this example, we're going there. So, same thing with math. There's going to be rules in a piecewise function, and it says we're going to say, okay, if the numbers are a certain way, we're going to put them into this equation, and if they're a different set of numbers, we're going to put them in here, and they'll give us rules, and we'll see that today. Okay, here are the steps. Find out what number is being placed in for x, for the function of x. Input the x into the function. If it's a piecewise function, input x into the right function, and then evaluate the function through orders of operations, which is PEMDAS. Okay, so pause the video right now. I'm going to move on. Here we go, number 1. Watch carefully. So it says evaluate f of 6, okay? So, meaning our ingredient we're going to put in is 6 as a number, okay? That's the input we're going to put in. That's our domain. So, and it's saying to put it into this function. So, instead of x, it's asking us to put a 6 in, okay? Because it says that right here, okay? So, we're just going to copy everything else down. So, f of 6 is equal to negative 3 times 6 minus 10, because there was an x there. I'm inputting 6 instead as our input, okay, as our ingredient. And what happens is we use orders of operations. So PEMDAS are in parentheses. Now there's just a 6. It's being multiplied to negative 3. Exponents now, multiplication, yeah. Negative 3 times 6 is negative 18 minus 10, okay. And then we have a subtraction problem, so negative 18 minus 10 is negative 28. So that means when I put the ingredient f of 6 or the ingredient 6 into our equation, I get negative 28 out. Okay, does that make sense? That is the output or the range. Does that make sense, everyone? Okay? Okay, again, number 2 now. Find f of negative 3 and f of 2. So it's saying here are your two ingredients, negative 3 and 2. I want you to put it in. But it's telling us there's a rule here. It says if x is less than 0, then use this one, and if x is greater than or equal to 0, use this one. So we have to kind of think about which machine we're going to put it into. Okay, so let's start with f of negative 3. We know f of negative 3 is less than 0. Isn't negative 3 less than 0, right? So we're not going to put it into the second machine, because this machine is used for, or function is used for, bigger numbers than 0. So we're going to use this one. It says negative x. So we're going to go f of negative 3 is equal to negative x. Okay, so instead of x, I'm going to put negative 3. So we put instead of x, we're putting negative 3. And a negative 3 is actually positive 3. So we know f of negative 3 is positive 3. Okay, but we're not done yet. It's asking us to do another input, which is f of 2. So we know f of 2 is bigger than 0. So we would want to use this rule right here and use this particular function. So it's going to be x plus 1, and instead of x, we're going to put the input of 2. So we're going to do 2 plus 1, which is also 3. 3, right? So in this one, on these two specific numbers, we got the same output, okay? It's still a function. It's still one output per input. And that's it, okay? Any questions? Okay, good. So let's have 1 cell 2 is about number 1, and then 2 cell 1 is about number 2. Ready, set. Okay, number 3, it says f of a equals negative 3a plus 5 to find the range with a given domain. So this one gives us the rule, okay?
I get a different iPad like every time.
Okay, so on this particular one, we get f of a is equal to negative 3a plus 5. That's the rule. And then it gives us some inputs. These are our ingredients right here, negative 3, 1, and 4. So you could even do what we did yesterday. Let's just make a table. Right? We know that we could make a table from yesterday. But we don't have to graph. It doesn't tell us to graph. It just tells us to use find our range here. So we got negative 3, or I'm sorry, f of a is equal to negative 3a plus 5, okay? And this shouldn't be x anymore, actually. I'm going to change this to a here on the top left. Okay? And then we have our inputs. Okay? Our first input is negative 3, so let's put this one in. Negative 3. If f of negative 3 is equal to negative 3 times negative 3 plus 5. Okay, what's negative 3 times negative 3? 9, okay. What's 9 plus 5? How much? 14. So if I put in negative 3, I get positive 14 out of this machine. Okay, continuing on. What's the next one? What's the next input or ingredient we would do? 1, okay. So you can use a table like we did yesterday, okay. What happens if I put 1 in? We got f of 1, which is equal to negative 3 times 1 plus 5. What's negative 3 times 1? Negative 3 plus 1? Negative 2. So if I put in 1, we get negative 2 as our output. Okay? Last one, 4. On your iPad, show me what the answer is or what the output is if I put in 4 into this function. Ready, go. Yeah, right. Right here is supposed to be a 5, sorry. Negative 3 plus 5 is positive 2. Sorry about that. Accidentally put 1 there. Anyway, it's supposed to be plus 5. So this last one's going to be f of 4 is equal to negative 3 times 4 plus 5, okay? Okay, finish it off.